example 1 for section 2 of chapter 5. We're solving exponential equations algebraically. So the trick with this is taking our base, identifying our base, and rewriting it as the same exact number. So if I take 4 and I times it by itself 3 times, I get to 64. So that means I can rewrite this 64 as 4 cubed. Now this 64 is being raised to the 7th power, so this 64 is being raised to the 7th power. And then when I raise powers to powers, I multiply my exponents, right? So then I get 4 to the 21st. Okay, and now since the bases are the same, the equations are equal, that means our exponents have to be equal. So I can set them equal to each other and then solve this linear equation, right? Subtract 1, divide by 4, or divide by 5, excuse me, and I get the answer of 4. And then I can plug this back in, right? 5 times 4 is 20, plus 1 is 21, so 4 to the 21st. Put that in my calculator, and then check what's 64 raised to 7th, and that indeed is the same answer. These are the same answer, so this x equals 4 is true. Now the second one's a little bit difficult. We got 1/2 a fraction, and we got 16 a non-fraction, but I know that this has a 2 on bottom, and I know that 16 I can rewrite as 2 to the 4th, right? So this is 2 to the 4th, that's 16, but that 16 is being raised to 2x minus 5, right? But this is still a fraction. Well, how do I change 2 into 1/2, right? That would be a -1, flips that fraction, right? Create a fraction. This then flips, and that becomes a positive exponent, right? So I can take 1/2 and flip that to 2 to the -1. So I could rewrite this 1/2 as 2 to the -1. And that 1/2 is being raised to 4x minus 16. So 2 to the -1 is raised to 4x minus 16. Now since these are both equal and the bases are the same, we can set our exponents equal to each other. But first I have to use my rules of exponents. Take -1 times my exponent 4x and the -16. So that'd be -4x plus 16. And then this, on the right-hand side, I got to take this 4 and multiply it by my exponents. Exponents times exponents. And I get 8x minus 20. Now I can solve this equation, right? Add 4x to both sides. Add 4x to both sides. So then I get 12x minus 20. 20. Add 20 to both sides. And then I can go ahead and just divide by 12, and I get x is equal to 3. So then I can plug that back in. I can take 4 times 3, which is 12, minus 16 is -4. -4 to the 1/2, that negative is going to flip it to 2. 2 to the 4 is 16, right? Now I can do the right-hand side. 2 times 3 is 6. 6 minus 5 is -1. Or just +1, sorry. 16 to the first is 16, and 16 does equal 16, so x equals 3 is true. So that's how one way to solve these exponentials is getting the same base. And then when I raise powers to powers, I multiply. If I have two terms, I got to make sure I distribute to both of them, then set the exponents equal to each other and solve for x and check it.